Okay, so number 11, contaminated chicken. In January of 2007, Consumer Reports published their study of bacterial contamination of chicken sold in the United States. They purchased 525 broiler chickens from various kinds of food stores in 23 states and test them for types of bacteria that cause foodborne illnesses. Laboratory results indicated that 83% of these chickens were infected with Campylobacter. I have no idea what that bacteria is. Construct a 95% confidence interval. So, step 1 is always conditions for an interval. The conditions have to be met so that a normal model is appropriate to create this interval with. So the first condition is randomness, right? Your book is going to say plausible independence. Is it reasonable to say the chicken is independent? Yeah. It's reasonable that each chicken is independent of each other, but that's really because the sample should be representative or random. Now, it doesn't say that they randomly went to 23 states and different stores, but I'm guessing they probably, when it's a national survey, they probably randomly selected which stores in which states. So we're going to say the sample is representative. Of the chicken sold in the U.S. 525 is less than 10% of all chickens. Broiler chickens in the U.S. Now, when we're checking this P, NP, and NQ, we have to use the sample proportion because we don't know what the actual proportion of the United States is. They haven't checked every single chicken in the U.S. They're taking a sample in order to estimate that. So we're checking NP hat greater than or equal to 10 and NQ hat greater than or equal to 10. In our sample, did we get more than 10 successes and failures? Okay, because we don't know the population proportion of chicken that have this bacteria. So that's 525 times 0.83 and 525 times 0.17. So 435.75 and 89.25. Now, I've gotten quite a few of you on the quiz so far for not writing your sentence about conditions being met. Okay, since conditions are met, a normal model is appropriate. And in this case, we're going to say I will use a one proportion Z interval. Okay, we need to state by name or formula what test or interval we are using. So this becomes a really big part of getting full credit on the AP exam, stating which test you're using. Now the formula looks like this, and memorizing all the different formulas is not as fun. It's P hat plus or minus Z star times the standard error, which is P hat Q hat over N. It's the standard error now because we don't know P. We're using P hat to estimate the standard deviation. And so my P hat is 0.83, right? Given in the problem, N is 525. So 0.83 plus or minus, it says 95% confidence interval. What is the Z star for 95%? 1.96. That's not going to change for the rest of the semester for Z stars. So once you have those memorized, it just makes that calculating easier so you don't have to go into the tables to find it. And that's the square root of 0.83, 0.17 over 525. So in my calculator, I'm going to put 0.83 minus 1.96 times the square root of 0.83 times 0.17 divided by 525. I can put it in as one big sentence. I don't really need any parentheses. The calculator is going to do the order of operations correctly for me. So I hit enter, and I get my lower bound, 0.798. And then I hit second enter, second enter to pull it up again. And I just scroll back to the minus and change it to plus. And there's my upper boundary. So our interval is 0.798 to 0.862. Okay, so step 1 is check your conditions. Step 2 is calculate the interval. Or later on, we're just going to call it performing the test. And step 3 is interpreting, and it right here in letter B, it says explain what your confidence interval says. So step 3, which is B, is interpret. And that's our cookie cutter statement. I am, or we are, 95% confident. The true proportion of chicken with Campylobacter bacteria is between, no parentheses, 0.798 and 0.862. I believe that this is what's actually true of the population based on my sample. That's what we're calculating. Okay. Any questions? Part C says a spokesperson for the U.S. Department of Agriculture dismissed the Consumer Report's finding, saying that's 500 samples out of 9 billion chickens slaughtered a year. With that small number they tested, I don't know that one would want to change one's buying habits. Is this criticism valid? And the answer is no. This criticism is not valid because it's a large sample. Right? 500 is a large sample. It doesn't matter how big the population you're pulling that sample from. It's large enough to make some determinations. When they do presidential surveys, they survey 1,000 people out of 900 million. It still estimates what's going to happen on election day very accurately. So we can still use that information even though the sample is 500 out of 9 billion. It doesn't matter the size of the population as long as that sample is less than 10% of the population, which is definitely true. You see, but that's how people that are uninformed, people that don't understand statistics, are swayed by misinformation. They can read that and say, oh, well, yeah, that makes sense. That's only 500 chickens. But they don't understand sampling, and they don't understand confidence intervals, so they don't know that that doesn't matter how big the population is compared to the sample. It still estimates really well what's going to happen. Number 13, in a poll taken in March of 2007, Gallup asked 1,006 national adults whether they were baseball fans. 36% said they were. A year previously, 37% of a similar size sample had reported being baseball fans. Find the margin of error for the 2007 poll if we want 90% confidence in our estimate of the percent of national adults who are baseball fans. So margin of error is the Z star part of the equation. Z star times the square root of P hat Q hat over N. What is the Z star for 90% confidence? 1.645 times the square root of 0.36 times 0.64, over 1,006. Make sure your two proportions add to 1, right? P hat and Q hat, these two add to 1. What just happened? There we go. These two must add to 1. So we'll do that calculation. And again, I don't need parentheses or anything around this. 1.645, put in the square root, 0.36 times 0.64 divided by 1,006. My margin of error is 0.0249. Explain what the margin of error means. It means they believe that the actual proportion, okay, the actual proportion of baseball fans varies by about 2.5% above or below the sample. It means that they believe the true proportion of Americans that are baseball fans is between 0.335 and 0.385, right? That's what our interval means if we round it to 2.5%. Somewhere in there. If we wanted to be 99% confident, would the margin of error be larger or smaller? Larger, right? If I want to be more confident, I have to have more values in my interval. So it's larger, and my z-star is larger to reflect that. My z-star is 2.5 something, 2.593 or something for 99%. So if I'm multiplying by a bigger number here to be more confident, my interval is bigger. Okay, so for C, 99% would be a larger margin of error, which would then make the interval wider. And then it says find that margin of error. So we're going to go to the back of the book real quick. It's 2.576 is my z-star for 99%. I got that from the table T at the bottom. And that's 0.36, 0.64 over 1,006. And I can just hit second enter, and I'm going to change my z-star to 2.576. And that's 0.039. It's 898. So 0.039. So there is the proof that it is larger for 99%. And then in general, if all other aspects of the situation remain the same, with smaller margin, will a smaller margin of error produce greater or less confidence in the interval? So if we keep everything else the same, the smaller interval is less confident. Right? If the sample size stays the same and the proportion stays the same, then a smaller interval is less confident. Do you think there's been a change from 2006 to 2007 in the real proportion of national adults who are baseball fans? Yes, Layla. No, it just says calculate the new margin of error. Find the new margin of error. So you can just say 0.039. And then, do you think there's been a change? If we think this is the interval, okay, if we think our 90% confidence interval is 0.335 and 0.385, is the proportion from 2006 within that interval? The proportion from 2006 was 37%. Is that in my interval? Yes. So when a value from a previous year is within the interval, it means it's a plausible actual value of the national number of fans. So it's totally possible that it's still 37%. We just got a sample that differed by 1%. Questions about that? So when it's within the interval, we believe it's possible for that to be true. Okay, if it's not in my interval, then we're not that confident that that's a true proportion for, right? If one year it was 39% and the next year it's 36%, well, 39% isn't in my new interval, so maybe the number of fans has decreased. And that's why it's important to kind of see some of these margin of errors, because when you see a change of 1% from one year to the next, oh, our graduation rate dropped 1% this year. Well, is that actually because something's wrong, or is it just normal sampling variation from one year to the next? Is it just natural variation, or is it actually, oh, we're doing something wrong, we had too many kids drop out, or whatever it is? So that's where we learn to be more skeptical when people start talking about small claims, right? One of the things that affects the size of an interval is the sample size. The larger the sample size, because that's in the bottom of our standard error calculation, it decreases our interval. So with small sample sizes, you're going to get a wider interval. With a large sample size, you're going to get a smaller interval at the same confidence level. So remember that our steps are conditions, perform, the test, which is the interval, and 3, interpret. This is going to be really consistent all the way through. We have to check conditions, perform the test, and interpret our results. Later on, those interpretations will be called a conclusion. Okay. So what is my p-hat in this case? 0.27. Why isn't it p? Right, it's not the true value. It's just what we got from our sample. Will we ever know exactly how many people get cured from this medicine? Probably not. Right? Some people take a medicine, feel better, and never follow up with their doctor. So n equals 53. So my conditions, the sample. Okay, so now we're talking about an experiment. We're not talking about a sample. When we're talking about an experiment, we can't say the sample is random because we don't randomly select people for an experiment. I can't randomly say, hey, you're going to take this drug, even though you don't have the problem that needs that drug. You can't do that for experiments. So when you're talking about experiment, you need to state that the experiment was properly randomized. Okay? Do we know for sure? No. But we're going to assume the experiment is randomized. So instead of random sampling, now we have 3 things we're looking at under that random sample umbrella. Was it a sample, and was it random? Is that sample representative of the population you're interested in, or was it from a randomized experiment? Okay, Faith.
I was just going to ask, obviously I know that for step 1 I'm doing conditions right now, but as you continue, can you write like next to the steps like 1, 2, 3?
If you wanted to.
No, I'm asking if you can say.
Oh, you want me to? Yeah. Sure. Like, sure, you can write that. Oh, you want me to write? Okay, yeah. Okay, so we're going to assume the experiment is randomized. If it doesn't say, it might say randomly assigned treatments, blah, 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 and it'll give you that information that, yes, it was definitely a randomized experiment. You want to state that instead of representative or random sample. Okay? 53 is less than 10% of all prospective subjects. If they're creating a new medicine for something, more than 53 people probably suffer from that something, right? And then my NP hat greater than or equal to 10 and Q hat greater than or equal to 10. So this is 53 times 0.27 and 53 times 0.73. That's 14.31 and 38.69. Now these numbers represent how many successes and how many failures they experience in this experiment, but you can't technically have 14.31 successes. You can't have 14.31 people get cured, right? So why am I getting a decimal? Because do you think 27% exactly found that cure rate, or did they round that percentage for their report? They rounded it, right? The percentage is rounded, which is why we're not getting a perfect, whole number for our NP and NQ. And that's okay, right? Very rarely do you hear them say on the news 43.895%. No, they say 44%, right? You don't hear them report to decimal places. They round to a whole percentage. Okay? So, since conditions are met, a normal model is appropriate. I will use a one proportion Z interval. Now, I won't be teaching you the calculator shortcut until chapter 20. You've got to understand these calculations by hand because they love those. What's the proper equation with all the numbers plugged in for your multiple choice questions? So step 2 is perform or calculate the interval. So my equation is p hat plus or minus z star times the standard error, which is square root p hat q hat over n. You're not actually given every individual formula for an interval. You're given the general idea, which is your sample plus or minus the critical value, which is your z star, times the standard error. It just says that in words. And then it has a table of all the different standard errors. And you have a table for your z stars. So these formulas aren't just there for you to copy exactly how they should be every time. We have to know in general how to calculate them. Whether we write that formula down or not, we don't get marked off for, because we said we're using a one proportion z-test. And that's good enough. So my p hat is 0.27 plus or minus 95% confidence interval is what z star? 1.96, 0.27, 0.73, sorry, over 53. Minus 1.96, square root of 0.27 times 0.73 divided by 53. So I get 0.1505 and .39. And step 3. Interpret the results. I am 95% confident. The true cure rate for this medication is between 0.15 and 0.39. Now I could say the true proportion of subjects that experience a cure. I can word that several ways, but you have to include the context in the problem. The context is the fact that we're talking about the proportion of people that experience a cure from this medication. Okay. Why is the interval so wide? It's because n is only 53. N is not super large, so my interval is going to be wider. Okay? Yeah, the interval is like, you know, it's 15, 24%. That interval is really wide, right? When we looked at that problem about the baseball fans, the interval was 0.25, 2.5%. That's only a 5% interval. This is a 24% interval. Why? Sample size, right? We're talking about 50 here. In the problem we just did, it was 1,000, right? The larger the sample size, the smaller the interval at the same confidence level.
Should we like state that when we interpret the result, like
No, no, it was just asked as part of like the lesson and discussing what happens. There will be questions, multiple choice questions, or even free response questions that ask you, like, if I change this, how will it change my interval? If I increase my sample size, what happens to my interval? It's smaller. If I decrease my sample size, what happens? It gets bigger. So we have to know that general concept. Okay. Okay, what if I change the confidence level to 90%? All my conditions are still the same. It changes my calculation to 1.645. Over 53. So in my calculator, I can just change it to 1.64. There's an insert button on top of delete. And I got 0.16, 0.17, and 0.37. So my new calculation, my interval got smaller, right? So that's an advantage. The interval is smaller. What's the disadvantage? Yes, we are less confident of capturing the true proportion.